Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilyas bin Muhammad Sofi with matrix number 307111. Okay, now we may start with the introduction. This assignment is to study the design of a database for MyEduTrack Plus. MyEduTrack Plus is a proposed centralized system to unify student information at all levels of education in Malaysia. The idea is for one platform to capture a student's academic and developmental journey from early years to postgraduate level. But this is not easy due to the different data formats, methods of assessment, and institutional requirements. This task, therefore, emphasizes understanding the system requirements, identifying the major problems, and developing an ERD that is flexible and capable of supporting sophisticated data relationships.
Assalamualaikum and hi, my name is Intan Nurasha Shafika and today my lecture number is 285812. So basically I will present about the requirement and interpretation. The system is my ID track system is an initiative by Ministry of Education designed to integrate student data across all education levels in Malaysia. The primary goal is to provide a unified, continuous view of student learning journey starting from primary school up to postgraduate student studies. And then, objective of the system is first one is a single student profile, which is to establish a comprehensive timeline that records student lifelong development, including academic grades, co-curriculum involvement, achievement, and also career progression. And then for number two, analysis and reporting to allow policymakers to analyze student progression patterns, evaluate the effectiveness of pathway, and make data-driven decisions. And then the third one is unified viewing to add an integration layer that harmonizes different systems and structure from various educational institutions while returning necessary detail. And then for the key problem and also challenges, that identified from the case study is inconsistent academic structures and assessment format, which is primary and secondary school use mix of traditional marks, descriptive evaluation, and tahap penguasaan, which is TP level from TP1 until TP6. And then secondary school must manage both continuous classroom-based TP record and structured exam result. For example, SPM. And then matriculation and university really heavily on course module, program stream, credit hours, and GPA. Number two, student identify matching and notify identifier. In school system, MyCard is the modern identifier. However, for the secondary level like SPM, students use candidate number and school ID. Once they enter university, they are assigned to a completely different student ID, which is a single student can have a multiple record across various system, leading to high data level fragmentation and duplicate profile. And also for number three is complexity of co-curricular activities and progression. School focus for structures category such as club, sport, uniform with internal scoring, role or descriptive achievement, while university track complex activities like student leadership, international mobility, and community engagement. And then some institutions record everything formally for transcript, while others do not capture informal activities in a structured database. And then for the highlighted ambiguous or conflicting requirement, first one is generalization or specialization for academic record. The conflict is Encik Rahman Ministry Policy Division on a single standardized view at a high comparison across all education stage, while Dr. Kumar IPPA representative argue that oversimplifying the system into a single structure ignore distinct academic areas such as fail or pass, courses, repeated module, and credit transfer. And then it leads for a single database design that create data loss while creating separate structures, restrict cross-level tracking. And then For the second one is classification of pre-nested pathway. Each advisor have information or access to program as a functional listing. However, Dr. Kumar objects pointing out that administratively these programs are run directly by listing. That's all for me. Thank you.
Based on the identified ambiguities, I developed a several key assumptions to guide the system design. First, since students have multiple identifiers across systems, I assume a single student entity with a surrogate key, while storing all identifiers separately to avoid duplication. Second, academic structures differ across levels. So instead of forcing a single format, I use generalization with specialization to preserve differences, such as TP, exams, and GPA. For curricular data, participation, roles, and achievements are treated as separate but related components to avoid oversimplification. I also assume that programs can belong to multiple categories due to classification ambiguity, and that the system must support hierarchical relationships and timeline tracking to reflect progression. Additionally, incomplete data is allowed to handle real-world inconsistencies. For future expansions, the system is designed to be flexible. Scholarship tracking can be added through a separate entity linked to student. Disciplinary and behavior records are handled using a generalized event structure. Employment tracking is supported through a post-education entity, and skills or certification can be added independently. Overall, this assumption ensures that the system remains flexible, scalable, and capable of supporting future requirements without major redesigning.
Hello, Assalamualaikum warahmatullahi wabarakatuh. So, my name is Muhammad Zakib and relative number matric 286395, and I will be talking about the ERD diagram. So, the ERD diagram, so the diagram, as you can see, represent the conceptual design of the MyEdu track plus system using the YAML-based ERD. It shows the main entities, their relationship, and how the system handle complexity across the different education levels. And I start with the student identity first, which acts as the core of the system to handle uh, the student identity will handle the difference across student education levels. I use generalization where student is a superclass is according to the case study. So the subclass will be include like school students, matriculation students, and university student. Three types of students. This is defined as a disjunct and partial, meaning a student belong to only one category at a time, and not all students must belong to a subclass. So for the part of the program and institution, and the we will declare as the program entity will represent the academic programs as diploma and degrees. It connect to the institution where one institution offers many programs. This reflect real world structure such as university offering multiple courses. So let's go to the next part of the program. This is a program has self relationship labeled as leads to will be represent the academic progression. For example, in the real world, diploma will you as a diploma student can be leading to the degree student. So from this allows this to model students pathways. So for the academic records, we will put the academic record entities to store the student's performance. A student can have multiple academic records representing different types of like a TP and as a results and GPA. This flexible structure allow integration across education levels. And also from the case study, we get the something like bonus part, like activity and participation from the students. So for the curricular activity, I separate the design into the two parts, into the activities and participation. Participation is I model it as class instead of simple relationship because it contains its own attributes such as role, achievement, and merit points. This allows a more detailed and accurate representation of students' involvement. Activity also include a self-relationship called as progression. This model level such as we can see from the case study, from the school, and go to the district, and go to the state, and go to the national. So it helps to track advancements from the student in competitions. And yes, from the institution hierarchy also, we have the hierarchy relationship where one institution can contain subunit. For example, from the university, you can see the highest ranking the authority from the university and goes to the faculty and goes to the department. From the authority from the main university goes to the authority from the faculty and then goes to the minimal part is called department. This reflect real world organization structure. So the diagram also includes the student enrolling in the program. So it will be called like a many to many, and student having multiple academic records and student participating in activities. This relationship represent the core interaction in the system. So for the future entities, at the bottom I say, additional include for the future expansion, scholarships, discipline records, and employment. This allows system to extend beyond academic into full student life cycles tracking. Overall, this ERD is designed to balance flexibility and structure while accurately representing real-world educational process.
Now that we've come to the end, we may conclude that the design of the MyEduTrack Plus system must take into account multiple education levels with diverse and sometimes conflicting requirements. The proposed database design should be a compromise between standardization and flexibility to enable a meaningful integration of data without loss of important details. By solving ambiguity, complex relationships, and future expansion, the system can provide a complete and scalable solution for tracking a student's lifelong educational development. That's all from us. Thank you.